All right, these next two problems, or this next group of problems, wants us to express each series as a rational function. So we're going to be taking a series and doing the reverse process of it and changing it back into a function. So the first one, number 70, is pretty straightforward. The only issue is they gave us this n equals 1. They did the same thing with number 71. Well, in order to make that rational function, we need to put it at n equals 0. So what do we have to do to get our sum to go from n equal 1 of this to n equals 0? Well, I mean, that simply just allows us to take out a 1 over x squared, because each x, it's 1 over x squared to the n, so 1 over 2n, so 1 over x squared for each time. And that'll be multiplied by the sum of n equals 0 now to infinity. And what are we left with? 1 times x squared quantity to the n. This is just adding one more time. In order to get that, we can multiply through by this 1 over x squared and get to that n equals 1. So it's not too terrible, not really tricky. So we've got it in this form. We need to put it into a form where we have, the 1 over 1 minus x, something like that, right? Or some value. We'll call it u. So we've got our 1 over x squared, and here our u is going to be this negative 1 over x squared, because we have it as a positive there. So it's going to be 1 over 1 minus 1 over x squared. And what happens when we distribute the x squared in the denominator? Well, we're still left with a 1 up top. Then we've got x squared times 1, and then that's just going to be simply minus 1. And that's going to be our rational function. And again, as a check, we can certainly put it into this form. All right, now 71 is a little bit more challenging. All right, so what does this equal? Again, we've got that n equals 1 to deal with. But we've also got this 2n minus 1. So I got this issue here. So I think the first thing I'm going to do is change that to just 2n. And how do I do that? Well, I've got an extra x minus 3 in the denominator, so let's just pull out an x minus 3 and put it in the numerator. I've got x minus 3 times the sum n equals 1 to infinity. 1 over x minus 3 quantity to the 2n. So, you notice if you multiply through by x minus 3 there, in order to put it in the denominator, you'd have to have an extra one to cancel it out with. So, all right, and again, if it was plus 1, I could do it a different way. All right, so what happens at this point? Well, again, we want to put it into the n equals 0 scenario. So we still have that x minus 3. And now we have a similar situation where our u here will equal this x minus 3 quantity squared. Again, because it turns our sum of the n equals 0 to infinity of u to the n equals this. So we've got it as a u to the n. It's 1/2 that, but whatever. So that's going to be multiplied by 1 over our x minus 3 squared times our sum n equals 0 to infinity, 1 over x minus 3 squared, all to the n. So now we've got it in the situation where we need it. We've got the 0. We had to pull out another x minus 3 squared in order to do it. We did the same process at number 40, or excuse me, number 70. And this should be, I've got a problem here. X minus 3, not 3, not minus 3. All right, I'm not going to cancel these out yet because I'm going to use them. I could easily cancel them out and then have to bring out more, but I'm just going to leave them alone because I know where this is going. So we have this x minus 3 over x minus 3 quantity squared, and then we have our big guy here, this 1 over 1 minus this whole thing's to the n. We've got 1 to the n as well. We can actually just do this. So that's going to be 1 over quantity x minus 3 squared. So that's how we're converting the summation into the function part. And now I'm going to distribute the denominator. So I'm going to leave the x minus 3 up top. I'm going to distribute the denominator, so I get x minus 3 quantity squared minus 1, right? And I probably should put this into a polynomial form down there because they want a function. This is probably satisfactory, but I'm going to give it one more step, maybe 2. So I'm going to FOIL that out. 6x and then what, plus 9. And so ultimately we get x minus 3 over x squared minus 6x plus 8. And that's probably a better answer if it was something like x minus 3 to the 5th power or 6th power. I don't want you doing that. But here it's just a simple FOIL and combine, so that shouldn't be too bad.